Hello everyone, I'm jw5728. I'm recording this for the EC6303 Homework 10. And for now, let's look at the first question. First question needs us to collect the definition and the simple property for the whole bunch of the process. And actually, I will focus on the Poisson process and the telegraph process, random walk, and the winner process. And actually, I need to verify the mean of the process, and I also need to define the correlation of the process, and that's it. And let's look at my solution for this problem. So the solution here, so the first thing is the Poisson process. And we know that the definition is given by the e to the power minus lambda t. And then this is the graph of this Poisson process. And we can write down the first order, and we can write down the expectation and the autocorrelation. And also we can write down the covariance of this Poisson process. And the second thing we have is the Poisson increments. And we know that the definition is given here. And we can also write down the first order probability masses is yt equals to n divided by epsilon, and this is what we have for the Poisson increment. And the mean value is very simple. It's just the lambda here. And then we can also write down the autocorrelation. We need to separate into two parts. The first part is the T1 minus T2 greater than epsilon, and T1 minus T2 is less than epsilon. Actually, I forgot to discuss more about the Poisson process. The longer we wait, and the expected number of value is larger. And our correlation function contains a term mean come from the independent here. And then let's look at the point impulse. Point impulse is basically just the Poisson process with the delta function. And we can basically write down the expectation, autocorrelation, and autocovariance. The process Ct minus lambda has zero mean, and autocorrelation is defined like this. It's called short noises in the. It's like this fixture within the time. And we know that the impulse in response, and the input is a Poisson impulse process. And this is LTI system. LTI system is what we define for this problem. And the third one and the fourth one is the semi-random telegraph signal. And the definition is written like this. And we can also write down the first order probability masses, and also the means, autocorrelations, autocovariance as above. And the thing we need to discuss is the pxt equals to 1. So it's not 1 minus 2, because it starts with the 1. And pxt equals to 1 should be a little higher than 1 divided by 2, as the ext equals to e to the power 2 lambda t goes to 0 when t goes to the infinity. that match our common sense when T1, T2 are far away and the T1 and T2 are less correlated. The fifth one, we need to focus on the random telegraph signal. And for this one, we also have the definition here. As I just mentioned, that we need to focus on this part. And the first order probability method is just the yt equals to 1 and minus 1 is equal to 1 divided by 2. And because we can like define that the ayt is basically just pa equals to 1. And this is simple as the same. We can define it as 1 minus 2, and it's very easy to calculate the mean value and the autocorrelation, autocovariance for this problem. This one is quite easy. The only thing we need to focus is that it's equal to 1 minus 2, 1 divided by 2, because it's a strict stationary, and EYT is equals to constant. Random walk here, so this is random walk for the sixth one, and we have the definition here, and then we can write down the expectation value, the autocorrelation, autocovariance. And autocorrelation has the property that contains a term of mean T1, T2, which comes from the property of independent increment. And the last one is the Wigner process. Wigner process has the definition here, and we can also write down the mean value and the autocorrelation and the autocovariance value. And we can check the Wikipedia to see more properties, and basically it has very nice property that W0 is equal to 0 with respect to 1, and W is independent increments, and it also has the Gaussian increments. Also, it contains like a path, increment path. Also, the limitation of this one goes to 1. It's a very good property. That's all for this problem. Thank you all.